A computer server room has a protective system to limit the effects of fire. The fire protection system is made up of smoke detectors, which are connected by a power supply to a mechanism for releasing gas, which will suppress the fire. This fire protection system won't prevent a fire happening in the server room, and it is estimated that, in this case, a fire is likely to occur in the server room once every 5 years. The company have invested in the fire protection system, so what they want to know is how reliable the system would be at controlling a fire and how often the system is likely to fail. Or, in other words, how often it is likely for a fire to be uncontrolled. One way to estimate the probability and frequency of a system succeeding or failing is to use event tree analysis. Event tree analysis starts with a potentially hazardous initiating event and ends with the possible consequences of the event, including the probability of a situation being controlled or not. To calculate the probabilities and frequency of success or failure, you need to know how often the initiating event is likely to happen and the reliability of each part of the system. We know that, according to estimates, a fire is likely to occur in this particular server room once every 5 years. To use the frequency of this event in the event tree analysis, we need to express this as a decimal. So, a frequency of once every 5 years is expressed as 1/5 as a fraction, which is then expressed as 0.2 times per year. We also have reliability data for each of the components of this particular fire protection system. We have all of the information we need, so now we can construct the event tree. Make a note of the headings. Start with the initiating event, then list in sequence what happens next, and end with the consequences. In this case, the initiating event is a fire in the server room. What happens next is that the smoke detector detects the smoke, the power supply is connected and working, and this then activates the mechanism that releases the gas, which extinguishes the fire. The direction of the arrows in an event tree have meaning, so why not make a note of this as a reminder for you when you are constructing the diagram. An arrow that goes up indicates yes or success. An arrow that goes down indicates no or failure. Now you are ready to start constructing the event tree diagram. Let's start with noting the initiating event and any other information you know about it, like the frequency. In this case, the initiating event is the fire, and we know that the frequency has been estimated as 0.2 times a year, or once every 5 years. Next, we consider each of the things that happen in turn. For each one, we ask if it happens. Remember, the up arrow indicates yes. What is the probability of this? And if it doesn't happen, remember the down arrow indicates no. What is the corresponding probability of this? Remember that a probability for an event always adds up to 1. So in this case, we ask, does the smoke detector work? If the answer is yes, the reliability data we are given indicates the probability is 0.9. If the answer is no, we can calculate the probability of this as 1 minus 0.9 equals 0.1. If the smoke detector doesn't work, then we move straight to the consequence of this failure, which would be an uncontrolled fire. If the smoke detector works, we move on to the next event that should or could happen in this system. Is the power supply connected to the gas release mechanism and working? If the answer is yes, the reliability data we are given indicates the probability is 0.99. If the answer is no, we can calculate the probability of this as 1 minus 0.99 equals 0.01. If the power supply connection doesn't work, then we move straight to the consequence of this failure, which would be an uncontrolled fire. If the power supply connection works, we move on to the next event that should or could happen. Is the extinguishing gas released? If the answer is yes, the reliability data we are given indicates the probability is 0.95. If the answer is no, we can calculate the probability of this as 1 minus 0.95 equals 0.05. If the extinguishing gas isn't released, then we move to the consequence of this failure, which would be an uncontrolled fire. If the extinguishing gas is released, the fire will be extinguished and under control. We have success. Now we have constructed the event tree and it has all of the data we need, we can calculate the probabilities of success, a controlled fire, and failure, an uncontrolled fire. We can also calculate the frequency of an uncontrolled fire occurring. If you want to have a go at the calculations yourself, press pause now. Then press play when you're ready to move on. Each path through the tree represents the probability that all of the events on that path will occur. Multiplying together all of the data along that path will give you this probability. The probability of a fire starting, the smoke detector detecting it, the power supply working and initiating the mechanism to release the gas, and the fire then being extinguished can be calculated by multiplying all of the data along this path in the event tree. Multiplying all of the data along this path will give us the probability of a fire starting, the smoke detector detecting it, the power supply working but the mechanism to release the gas failing to work, and the fire not being extinguished. Multiplying all of the data along this path will give us the probability of a fire starting and the smoke detector detecting it, but the power supply not working. This means the mechanism to release the gas fails and the fire is not extinguished. The probability of a fire starting, but the smoke detector failing to detect it and the fire not being extinguished can be calculated by multiplying all of the data along this path in the event tree. So, in total, the probability of failure can be calculated by adding the three probabilities of failure together. The probability of an uncontrolled fire has been calculated as 0.031 times in a year. To make this a bit easier for everyone to understand, we can express the frequency as 1 over 0.031, or once every 32 years. As this video has hopefully demonstrated, event tree analysis is a technique used to consider whether the parts of a system designed to reduce the consequences of a particular event work successfully or not. It is also used to work out the probability and frequency of these consequences occurring.